All right, here's a couple of questions, 3 dealing with transformations, and then 1 dealing with exponent log applications. So the first question, number 2 here, it says a point is given on the graph. So here's the point. So I have a point -1, 7. This is an x value, that's a y value. And it says find a point on this new graph, g of x, once it's been transformed. So they've taken the f of x graph, the one that this point is on, and they've done this to it and then that to it. So that -1 there means it moves right 1, and the +3 means it moves up 3. So if I take this point and move it right 1, because moving right or left, that'd be an x movement. If I move it right 1, that would get it to being a 0. And then if I take the 7, and if I go up 3 from that, that would give me a 10. So the point 0, 10 would be on the graph of g of x, whereas this one would be on the graph of f of x. Okay, the next question, you have to do the same thing with that. And so you need to take every point and apply the transformations to it. This is a relatively simple one, where here this says I have to go right 4, and this one says I have to go up 1. So I have to take each point. So here's one of the points. It's -4, 0. So if I go right 4, that would put me at 0. And then if I go up 1, it would put me right there. So my new point is right there. So that point there has been moved to be that point. Okay, the next point, this one here, I have to go right 4 and then up 1. So if I'm starting at -3 and 2, if I go right 4, 1, 2, 3, 4, and up 1, that would put me right there. And then the next one would be, I think, right there. Let's do this one. If I go right 4 and up 1, so over 4 and up 1, be right there. So the first part of that graph will look like that. And then this one is at 3, so I have to go over 7 and up 1. So over 2, 7, and up 1. So 7, I think that will put me here. And then this point, it's at 4. If I go over 4, that'll put me at 8 and go up 1. 8 and up 1, right there. There. So I've taken the graph and I didn't squish it or stretch it at all or flip it. All I did was move it over 4 and up 1. Okay, the next question is similar kind of thing. And what you could do on Desmos is you could graph that function. So just go y equals 3 to the x, see what that looks like. It looks something like this. And then this one tells me to go left 1 and down 3. So if I go left 1 and down 3, I don't know, the graph's going to look something like that. Okay, and you could confirm those graphs on Desmos. Okay, that's the transformation questions. Now here's another one. It says, a given isotope has a half-life of 950 years. Okay, just that information there will allow me to find the decay constant. So my formula is P of t equals P0 e to the k times t. Okay, so they say the half-life is 950 years. Years is a time, so I'll plug that in there. So 950, and then there's a k value. I don't know that yet. Now P0 and P of t, they say half-life. Half-life means it starts at a certain weight and goes to half of that. So say we start at 6. After 950 years, the weight will be down to 3. Okay, so to solve this equation, we've already done a few dozen of these. Divide both sides by 6. So I get 0.5 is equal to e to the k times 950. And then I'll change it to a log form. So log base e of 0.5 is equal to k times 950. Then I'll divide both sides by 950. Okay, let me just do that on my calculator quick. Now log base e is the same as ln, right? So I'll just use ln. So functions ln of 0.5, close the bracket, divide 950. Okay, it gives me a k value of negative 0.0007296, etc. I'll use that whole number later when I do the calculation. Notice it's negative, so that tells me that it's decaying or getting smaller. Then they ask the question, how many years, so they're looking for time, would be required for the given amount of the same isotope to decay to 45% of that amount. So not half, be 45. So again, I'll use the same formula, P of t equals P0 e to the k times t. This time I know what k is. So k up there is negative 0.0007296, etc. Times time I don't know. And this time they give me, it says decay to 45% amount. So I'm going to start at 100 and I'm decaying to 45%. To solve, do the same thing as we just did. So divide both sides by 100. So I get 0.45 is equal to e to the negative 0.0007296 times t. Again, now change it to log form. Log base e of 0.45 is equal to negative 0.0007296 t. Divide both sides by negative 0.000. I'm getting tired to write that number. 0.0007296. Okay, calculator. So ln of 0.45 and my bracket divided by negative 0.0007296,286. Well, it's not changing anything anymore. So t then will be equal to 1094. And that sort of makes sense because it says the half-life to go from 9 to, or 6 to 3 to go to half the amount is 950 years. So 45% is just a little bit more than that. So it'll have to be a little bit more than 950. I came up with 1094. That makes sense. All right, hopefully that helps you with those 4 questions.